I don't know exactly what to compare that to, but it's kind of fun. This is Jim Ringline. I'm the Curator of Science here at the North Museum of Natural History and Science in Lancaster, PA. And we've got a really great demonstration that we'll be sharing with the public, particularly this coming week between Christmas and New Year's here at the museum. The idea is that this superconducting material floating above magnets is really nothing new. Well, what's special about this crystal is that the sapphire itself has a crystal structure that keeps it stabilized when it's doing this kind of thing. So from its creators, they call this quantum levitation. And the reason that they call it that is because it's got a peculiar quantum effect related to the sapphire crystal that's in this. So first thing that I'd show you here is this is really the dynamic element of this that's been created by this group in Tel Aviv. This is a disc that has gold on one side. You can see the gold. It's really, the gold is just a protective coating on there. And then you can see on edge that it's very thin. And in the thin layer are two very important components. One is a superconducting material, and then the other one is a sapphire crystal. And what we do with the superconducting material is we've got to cool it down to liquid nitrogen temperature, which is really cold, only 77 degrees Kelvin. And the way we do that is we put together this little package, which is what I'm going to do right here. So we take a foam disc. There's nothing special about this, just a foam that I'm going to put on top of this right here and make sort of a covered disc out of it. I'm going to pour liquid nitrogen out into a container. We're going to put this disc in there. The liquid's going to get inside of here, get in with the foam and the other crystal materials, and then it will make it very cold down to the temperature where the superconducting material will really become superconducting. Take it out now, the excess liquid nitrogen out of it. I'm going to take a very strong magnet over here, put it right over top of it, and you can see that it floats. Now the interesting thing about this is having things float above other magnets is not that unusual. A lot of people maybe have played around with magnets floating on top of other magnets, but what's unusual about this is how particularly stable it is. I can twist it, and twist it like this, and it stays there. It doesn't want to rotate or jump around like other magnets would if they're up on top of other magnets, because it's not really a magnet, it's a superconducting material. I can even do this, I can even turn it over. Now, one of the other things that's really interesting about this is this one stays pinned any orientation, and if I try to twist it, it doesn't really do anything. But if I take it and I put it over top of this particular magnet here, now I can make it rotate. So I've had this out for a little while, so it probably has a little bit of coldness left to it. We'll see if it stays floating on there. I give it a spin, and around it goes. Now this track here, as a whole, the whole thing looks circular, but each one of the magnets points inward just a little bit. So that's what enables this thing to oscillate or go around this circle here in a circle, because it's got a magnetic field that allows it to do that. The Quantum Levitator will be here every day next week between December 26th and the 30th at noon every day, and on Monday, Thursday, and Friday we'll also have it at 2:30. So a 2:30 program, a noon program, about a half hour more or less, and you can see this thing live in person here at the North Museum of Natural History and Science in Lancaster.